Problem number 12 starts off a 3.5 liter gas sample. All right, so we've got our volume equals 3.5 liter at 20 degrees Celsius. So here we have our temperature. Gonna leave some space there. And a pressure of 86.7 kilopascals, and expands to a volume of 8 liters. Interesting. So this is going to have to be volume 1. This is going to have to be, we'll put volume 2. Volume 2 was 8.0 liters. What is the final temperature? Oh, so we got a final temperature. So that must be a T1. Final temperature is a question mark. What is the final temperature of a gas assuming the pressure stays the same? So P1, P2 are exactly equal to one another. So we could put equals P2. So those are the exact same. Now we do need to convert this here. Remember, we need to add our 273. So 273 equals 293 Kelvin. All right. So do we really need the ideal gas law here? We have nothing to do with moles. So we don't need the ideal gas law. And we really need to use the combined gas law. So we have our P1 V1 all over T1 equals P2 V2 all over T2. Now we want to know T2. So if we invert everything, okay, so just imagine you really need to flip everything. So now our T2's on top with our P2 V2 on the bottom, okay? That's how you need to imagine this. All right, so this really ends up being T2 equals, our T1's going to be on top, T1's on top, and our P1 V1 are on the bottom now because we inverted there. Now, even though we inverted, these guys are down on the bottom, we have to multiply by them on both sides to cancel them out on the right side. So we have to multiply by both, so they're going to be up on top. So P2 V2. All right, now we just plug in our numbers. So we'll bring that down over here. Our T2 equals T1. Our T1 was 293 Kelvin. And our P2 was exactly the same, kilopascal. And our V2 is now 8.0 liters, all divided by our P1, again, 86.7 kilopascal, okay, divided by our V1. Okay, liters cancels out. Those two numbers completely cancel out. And so what you've got to do is you're going to end up with Kelvin, and you need to crunch in these numbers. So 293 times 8 divided by 3.5 gets you 669.7 Kelvin. And there we are with problem number 12.